All right, guys. Talking about the test from Friday. I do not think it's a useful kind of use or consumption of class time to go over the test that we took. Okay, but I'm not saying that's not important to do that. Okay, if we were to take 13 tests and we do a review before we do the test, and we do a review after, that's 39 days, right? And we're not gonna get things done in 180 days. Okay, so there's no way that we're gonna get through all the material in a fashion that I want us to. So there's no way that, or it doesn't make logical sense to spend time reviewing something if I've got other techniques for you to review it. Does that make sense? If we can use other means of doing that kind of stuff, I'm going to do that. So under Chapter 1 here, okay, you're going to eventually, and this will be posted by tomorrow, you're going to go to the red stuff here, okay, Chapter 1 test, quiz, worksheet, reviews. You're going to click there. It's going to take you here, okay. I just got to find the video and post it there, okay, of me taking the test and explaining the questions like it was the first time they've been explained to you, okay. And I think that's going to take place of the review that we do in class, okay, because I think you could be anywhere on the spectrum of skill or mastery on that test, where if, let's say Drake got 100 on it, okay. Am I wasting his time if I spend an entire 50 minutes going over that test and reviewing? Yeah, he's not getting better that day, right? Okay. Let's say Drake got a 20% on it. There's not enough time in that 50 minutes to fix all his mistakes. Does that make sense? Or his errors? So regardless of where you are, you're either going to need less time than what we go over, what we use in class, or you're going to need more time. So putting it as a video for you to review allows you to go see the ones that you messed up on and try to get that explanation and get that fixed. Okay, and it allows you to, if you're that person that's at the bottom of that spectrum, it allows you to pause things, to rewind it, to go over it again, and to see your mistakes in a little bit more of a time frame that's maybe comfortable for you, instead of us flying through it during the period. Does that make sense? So my hopes are that you use that. Okay, I'll try to do that on every test. Okay. And I think that could be beneficial because I also allow you to retake tests, right? Okay, so I'm going to post that, all right, and we're going to talk about it in the video on how to address certain problems. And if you are able to take the test, if you've got the opportunity to retake the test, that should be maybe a pretty good tool for you to do well the second time, right? Okay. And talking about taking a test, so this is just kind of like a fake student that I put in the progress book, okay, and just put some random values in for their scores here. But this is what you guys would see in your progress book right now, okay. I want to explain what the information you're seeing is. I think in some classes maybe, and I hear conversations between students all the time, well, he put a grade in that I don't even know what that means or anything like that, or I don't understand how he's doing his grades. I think it's important for me to share that with you and tell you how I'm doing it so you're all on the same page with me. So if we do have discrepancies or issues, we both are aware of how things are being conducted. So you see your, 6 assignments up there. Okay, 6 assignments. So I'm just going to highlight these real quick and explain where your points are coming from. All right. So 1, 2, 1, 3, 1, 4, 1, 5, 1, 7 midpoint, 1, 7 distance. Those are the 6 assignments that were inside Math Excel, okay? Every worksheet's a little bit separate. I just do the worksheets out of 10 points, and I average those instantly, okay? But those 5 points that you're seeing on those questions, or those ones that I just highlighted, those assignments I just highlighted, those are just for completing it. Does that make sense? Okay? Now, if you're a person that out of 25 questions, you picked and choose the 20 that you wanted to do, even though you got the 20 that you want to do right, you still have 5 left over that you did not answer, right? You're going to get a 0 for that. All right? It'd be like going into English class and writing the body of your paper, right, or the introduction, the body, and then leaving the conclusion off. You have to finish things to reap the benefits of those, right? Okay? So you have to finish your assignments to earn the completion points, or it's not complete. early on, okay, if you're missing 3, you're missing 2 or 1 or something like that, especially an assignment that is pretty big, you know, that assignment might have had 25 questions in it. Missing 3, okay, I'm going to give you a warning, okay? But this person, the next time I see them missing 3 or 2 or 1, they're getting a 0, okay? And this is actually everybody's warning. You don't complete the assignment, it's not complete. It's a 0, okay? You get to a job someday and they tell you to do this task and you do it half-assed, you do half of it or 2/3 of it, they're going to fire you, right? That make sense? Okay, I want you to get in that mindset. If you watch anything on the news or anything related to employment and the issues that people are having nowadays with employing young people, is because young people are not finishing their jobs. They're not following through with everything, and then they have to fire those people. And then, okay, so I want you guys to be those people that do finish their jobs. Train yourself to make things important and finish things so that you don't get fired. So that's what that stuff is, okay? If you have an incomplete or did not do over on the right-hand side, that will eliminate you from being able to do the retake for that chapter, okay? So chapter 2 starting today, and we wipe the slate clean, and you can start over with chapter 2. So if you have all your homework turned in for chapter 2, you'll be able to retake chapter 2's test, even though you weren't able to take chapter 1's test. Is that all right with everybody? Okay. So in the syllabus, I tell you your homeworks are all worth 10 points, but you're only seeing 5 points on each of these. Okay. The other 5 points for each of those comes from whether you got them right or wrong in Math Excel. So instead of averaging each one here, okay, kind of like I did in the worksheet. In the worksheet here, what this is saying is that this person got 5 for doing it, but got 1.5 for getting them right. Does that make sense? Okay. Instead of doing that for every single assignment, I'm going to wait to the end, wait till everybody's got everything turned in, and then I go into Math Excel, and I export all your grades. So what it's going to do is it's going to tell me that maybe this person got a 90 on that one, maybe a 72, maybe a 60, let's go 100, maybe another 100, and then an 85. Okay? And I just add those up, add those percentages up, and divide by, in this case, 6, or however many assignments there are. Does that make sense? And I get an average. Okay? So this person, maybe I got like it's like a 93. 93%, meaning they got 93% of the questions in this chapter in Math Excel right. I take that 93% and I multiply it by 30, and it gives me that 27.6 that you're seeing up there for that 30 points. Does that make sense? So that's what that assignment is showing up as. It is part of the other half of those 6 assignments. Okay? So I've had a lot of questions. People saw that show up. I got emails. I got people coming up during that time asking what that's all about. That's what that is. Okay? If you take the retake, number 1 suggestion, prepare for it. Okay? In the past, people will come, take the retake, do worse on it. Conversation I have with them afterwards is, well, what'd you do? How'd you prepare for it? They didn't. I saw it last week. I thought I'd do better on it just because I saw it last week. Okay? Just because you saw something doesn't mean that you're going to do better on it when you see it the second time. Okay? You need to prepare for it. Fix your misconceptions. Ask me questions during the week. That's why I give you a week to do it, is so that you can go through those processes of finding me, asking me questions, ask your friends questions, review the videos, that kind of stuff, review the lectures. When you take that, okay, let's say that this person got 53 on it. If they take it and they get a 63, the 53 goes over in the comment section just so I have proof that you took it twice, and then a 63 goes in the spot where it actually gets calculated as your grade. Okay? If you do worse on the retake, let's say come in and you get a 43, and the comment section goes a 43 on the second test, and I keep the 53 where it does the calculation. So there is no penalty for doing worse on the retake. Does that make sense? Okay. I do think eventually, I do this with my juniors and seniors, if they're going to do a retake, if I give opportunities for retakes, they always ask, well, what if I do worse on it? Don't do worse on it. Okay? You have to be able to play that kind of risk game and assess the risk and guarantee that you're not going to do worse on it. Okay? But I'm not going to do that to you guys right now. You're ninth graders, 10th graders. I think my juniors and seniors a little bit more mature to be able to evaluate that risk. Okay? But that I'll do that with you guys when you get to those courses. Does that make sense? Okay, I just want to make sure everybody's on the same page as I am with how grades are done. Worksheets will never be incorporated inside this right or wrong aspect. Like I said, they are individual, okay? But you'll see worksheets out of 10 points. Some of the longer worksheets, maybe I'll give you 2 or 3 days to do them. They might be worth 20 points or something like that, but that's pretty rare. Usually they're 10 points. Do you guys think that'll help? Reviews that way? Okay. It's a unique opportunity to do those retakes, okay? Please take advantage of that. And you can do that as many times as you want throughout the year. All right, so section 2.2. This is going to be kind of a weird transition. It's not extremely hard. Okay, but it's a weird transition from the math that we've been doing to basically go back and talk about all the rules and properties that have been laid out for us and all the procedures and steps that we know to go through because of Algebra 1 concepts and Algebra 1 ideas. All those things are presented to us in what we call if-then statements or conditional statements. Huh?
I'll give you an extra laptop.
Yeah. I don't know how slow that one's going to be, but yep. All right, so conditional. Every rule that you have learned so far since your first days in a math class are written as what we call if-then statements or conditional statements, okay? And what we're going to do is, because it makes geometry so much easier if you can understand these structures of sentences and you can understand how we read them and how we interpret them, okay? You've all been in conversations where somebody says something and then you know that they meant something else, right? Okay, or you feel like they meant something else, even though maybe their words didn't say that. In mathematics, that should never be an issue. What is said is what we do. Okay, the rule that's laid out in front of us, that's the rule, and that's the only way we can interpret it. Okay, kind of talk about the way we deal with everyday language and how we interpret everyday conversations, and then how we kind of do that same thing inside a math kind of framework, okay? So you'll see you'll hear me talk about jumping over from like a math discussion to an English discussion or an everyday discussion, and there's a little bit of a difference, okay? Now this got cut off a little bit. This is a definition, and that first one that got cut off there is a conditional. So it should say C-O-N for conditional. The next one's hypothesis, and the third one's conclusion. Conditional is kind of a lame definition. They say it's an if-then statement. Okay? An if-then statement. And what this means, you guys, everything that we do in our lives is governed or directed by if-then statements. Okay? So in the last class, you guys play Minecraft? Anybody play Minecraft? Used to. Okay, somebody in the last class gave me an example. If I type in Minecraft, summon zombie, and type in like coordinates, then the computer is going to show a zombie show up, right? Okay? And I use that example because you guys are pretty familiar with technology. If I'm playing, you guys play Xbox, PlayStation, anybody does that? Yeah, a little bit, okay? So if I hit triangle or a top button playing football on Xbox, he jumps, right? Okay? If you push this button, then the computer does this, right? Okay? Or the instrument does this, okay? Whatever you do on your calculator, you are doing if-then statements, okay? If I push 5 plus 4, hit enter, thank you, then the calculator shows me a 9, right? Those are if-then statements. Everything we do, if your alarm goes off in the morning, then you wake up, right? Okay? If if it's foggy outside, then what's the first thing you do? Look at your phone, don't you? See if you got an alert? Okay, that's what I do. I do it every morning I wake up. Okay? Even before I look outside. Okay? Everything we do, if it's foggy, then we're delayed. If my alarm goes off, then I wake up. Every single interaction, every activity that you go through throughout the day is based off an if-then statement. Okay? Now, you don't think about it that way. You don't operate that way. Okay? But that's the way it is. You've heard me say the phrase, this class is going to make us think about the way we think. This is the kind of the start of that. Okay? There are two parts of an if-then statement. The if part, okay, is called the hypothesis. The if part is called the hypothesis. The then part is called the conclusion. Okay? I'm just going to write up a generic phrase here. So if it is raining, then the grass is wet. Okay? The hypothesis is that phrase right there. That's the hypothesis. This phrase right here, the grass is wet, is called the conclusion. Now, as we start dealing with this stuff, there is an infinite number of if-then statements that you can write. Okay? And they don't have to make sense at all. If it's October, then dandelions smell like cat pee. I don't know. Okay? That doesn't make any sense, right? That statement is dumb. But it's an if-then statement. Correct? Okay? The if part, if it is September, the then, or October, whatever month I said, the then part, dandelions smell. Okay? So they're all if-then statements. The hypothesis is the if part. The conclusion is the then part. But we can make, like I said, we can make an infinite number of statements. But I want to be able to talk about conditional statements collectively without having to look at a specific statement, without looking at a specific hypothesis and a specific conclusion. So what we do is we introduce these kind of variables that represent statements. So this P here represents all the different if statements that you could ever imagine coming up with. And they could be anything. Okay? The Q represents all the conclusions that you could come up with, all the then statements. Okay? Because it's just so much easier to write if P, then Q, than it is to write if it is raining, then the grass is wet. Does that make sense? Okay, so we're going to learn something about that if P, then Q structure, and that will allow us to learn stuff then about the specific scenarios like these here. Okay? Mathematicians are lazy, okay, in regards to writing things down. They like to create a lot of symbols and a lot of different notation that makes their work a little bit easier to write, but when you do that, you lose people. They get confused, okay? This is read as if P, then Q. That's what this arrow means, okay? It means if P, then Q. Or I can read it as P implies Q. P implies Q. I can rewrite that phrase down the bottom. If it's raining, then the grass is wet. I could rewrite that as rain implies wet grass. Does that make sense? And that would be structurally the same as if it's raining, then the grass is wet. Okay? So you can use, you'll see them transition between words like if and then, or the word implies, but they're the same thing. Okay? What I find weird, confusing, is that a lot of math courses don't talk about this stuff. They don't teach you how to read math. Okay? And if you don't learn how to read the math, then you're gonna be in a lot of trouble eventually. Okay? Because not only can we say we read, everybody can read, but can we comprehend what we're reading? Because that's different, right? Okay. But if I don't understand the structures, I'm not going to be able to comprehend it. Then I'm not going to be able to use it and apply it. Okay. So I'm trying to teach you how to read some of our math ideas. Okay. You don't need to write this down. This is just a different way of seeing the last slide. Okay, the P part's called the hypothesis, the Q part's called the conclusion. In your homework tomorrow, they're going to give you some phrases. Some will be mathematical, some will be non-mathematical. I'll ask you, what's the hypothesis? And you'll have to select a bubble that shows the hypothesis. What's the conclusion? You'll select the one that comes after then. Pretty easy process for understanding which one's the hypothesis, which one's the conclusion. This slide, you don't need to write this stuff down either. All this is saying is you usually don't incorporate the words if and then. They're just kind of identifiers. So if is not part of the hypothesis, then is not part of the conclusion. They just identify where those things start and finish. Okay? It's not a big deal. If at any time you accidentally include the word if or include the word then on a conclusion or hypothesis, it's not the end of the world. It's not a big deal. Okay? Here are some examples. These are some of these. I think all of these are mathematical. Okay? But I need us to understand how we can read these and interpret these. Okay? As we read if-then statements, okay, in order for us to use this and apply this statement, because this statement is kind of like a rule that's been posted somewhere in our text as a theorem or a definition or a postulate. In order for us to use that thing effectively, we need to be able to understand that the if part is telling me what is happening in front of me. Okay, so I've got a specific question that I'm working on. And it says in my specific question, maybe it tells me, it might say angle W is a right angle. Okay, maybe that's what I've got in front of me on my particular question. Okay, this statement here says if it's a right angle, then it's 90 degrees. Well, is my specific angle W a right angle here? If it's telling me that in the problem, does that make sense? If that's happening in front of me, then what's the conclusion I can make about angle W? How many degrees does angle W have? It has 90 degrees now, right? When your specific scenario, your situation that you're dealing with matches that statement, matches the if part of that statement, you can then make a conclusion about your object that aligns with what the conclusion of the statement is. Okay, I can say angle W now is 90 degrees. Okay? If they were to tell me in my work, angle W is obtuse, does obtuse match right? No. So I wouldn't be able to use it. I would not be able to make the conclusion then about my angle W if they say it's obtuse. Okay, I'm not going to be able to say whether it's 90 degrees or not. Okay? But this is a rule that we need to be able to recognize that if this part is occurring in front of you, if you know that the object you're dealing with is a right angle somehow, then you can make the jump that says, well, that angle then is 90 degrees. Okay? We can reverse this one. We can reverse it. Sometimes we like this idea where reversing it, it's just natural to reverse things, but it's not always true. Here I can. If I go, it is 90 degrees, if it is 90 degrees, or if an angle is 90 degrees, does it make sense then that it's a right angle? So you're working in front of you, you do some calculations, you find that the angle you're dealing with added up to 90 degrees, add a measurement 90 degrees. You can now classify that thing as a right angle, right? Okay, because your picture in front of you, your work, matched up with the hypothesis there in that second bullet. Now, the issue is, are all statements reversible? And the answer to that is no, they're not. We've already seen a lot of these that are not reversible. We had the phrase, let me write this one down real quick. If angles are a linear pair, then they are supplementary. And I'll make that larger. If I reverse that, if angles are supplementary, then they are a linear pair. All right, we saw that, and I'm pretty sure that was a question on our test. There were two questions like this. That top one, if the angles are a linear pair, then they're supplementary. Would you guys agree with that? Is that a true statement? And inherently, because that's true, our minds want to be able to reverse that and say it's true as well. Okay? But that'd be like saying Mr. Fay likes Hunter, so Hunter likes Mr. Fay. That's not true, is it? Or it might not be true. Hunter might not like me. Okay? Even though I like him, or I might not like him even though he likes me, right? Does that make sense? So it's not a two-way street. This is not a two-way street. If angles are supplementary, they might not be a linear pair. They could be, but they might not be. Does that make sense? So you can't just, when we see a phrase in mathematics that's an if-then statement, we cannot reverse them whenever we want to. Okay? And if it's written as if this, then that, they're telling you, don't reverse it, okay? The only time that you'll be able to reverse it is eventually, later on in another chapter or another section, they will introduce it reversed as an if statement reversed. Does that make sense? Okay? Later on, maybe tomorrow, we'll talk about how they can introduce another terminology, another phrase that will tell you it is reversible the first way you see it, okay? But if I see that phrase right there written down in the textbook, I don't want to reverse it, okay? Because they're not telling me right now that there's information that allows me to reverse it. Okay? You ever heard the phrase, like, mean what you say what you mean? That kind of thing? That's the logic that we're using here in this course and in all our math courses. Okay? They're going to tell us exactly what they mean. All right? And then we don't want to interpret it or assume otherwise, because then we're going to get in trouble. The things that are reversible, okay? Definitions are reversible. Definitions are reversible. And what I've got up there in those first two bullets with the right angle, that's the definition of a right angle. Okay, and you guys have done this. You've done this in other courses. You've done this year. You did it on the test the other day. If I give you a vocabulary word, you should be able to write out the definition, right? Or if I give you the definition, you should be able to turn around and just give me the word that goes with it, correct? Any definition should be that way. That should be reversible. If I give you a right angle, you should tell me that it's an angle that has a measurement of 90 degrees. Or if I start you with a definition, hey, this is an angle that has 90 degrees, you should be able to throw the word at me, right angle, right? Every definition is that way. Every definition is reversible. Okay? These over here are not reversible. So that must tell me that these phrases that we're talking about must not have been definitions. Does that make sense? Okay? Down here on the bottom it says, if two distinct lines intersect, then they do so at one point. That's an if-then statement that we've already seen in Chapter 1 about, well, that was one of our postulates. Okay? And I want to talk about that bottom one, because it's a little bit easier for us in this bottom one to visualize. If two distinct planes intersect, then they do so at a line. Let's think about this. We talk about how if we're going to use that phrase, if we're going to use that statement in a particular or a unique situation, then our situation needs to mimic this right here. Okay? So let's look at the ceiling and the floor. Are they planes? Ceiling and floor, are they planes? Yes, they are. Do they intersect? Does the ceiling intersect the floor? Nope. Okay? So because the planes that I'm dealing with, even though they're two distinct planes, they do not intersect, so I do not match what I underline there, right? So there's no conclusion that I can make about the ceiling and floor based off that statement. Okay? But does the wall in front of us and the ceiling, do the wall in front of us and the ceiling, do they intersect? Yes, they do. So how do they intersect then? Because I meet that if part, they're going to intersect at a line, right? Okay. Last class said that they did this a little bit last year with, just going to scroll down here, find me just scroll over. You guys do absolute value? Like equations with absolute value? So let's say I've got, so here's how the rule was presented to you. If what you're working on, if your particular problem looks like that, then you get two parts. You get an AX plus B is equal to C, and you get an AX plus B equal to negative C. Just kind of jog your memory a little bit with absolute value. What absolute value is, by definition, it's the distance something is from zero, right? Okay? So right now I'm saying the absolute value of something is C units from zero. So it's either right there or it could be there. So basically we're saying whatever X is going to put my AX plus B right there, C units to the right of zero. But because absolute value is a distance, it could be to the left of zero. That's why we get those two individual equations. Does that make sense? So last year you were working through problems and you get to something that looks like this. 2x plus 1, the absolute value of that is equal to 5. And here's the thing. That right there is your special case. That's your individual situation that's occurring. Does it match this rule? Does what I highlighted in blue, do those two ideas match? That make sense? Because they match like that, now obviously A, B, and C, they could be any real numbers. So here there's specific numbers, a specific case. If they match, then with this one here, I can make these two statements. I can say 2x plus 1 equals 5, and I can say 2x plus 1 equals negative 5. But I can only do that because my specific situation matched the if-then statement that was provided in my rule. Does that make sense? So now here's the issue, because I get this all the time. If I have 2 plus the absolute value of 2x plus 1 equals 5, can I turn that into 2 plus 2x plus 1 equals 5 and 2 plus 2x plus 1 equals negative 5? Can I do that? Because all I did was I got rid of the absolute value bars and I wrote the equation and I got rid of them and I wrote the equation equal to negative 5. Can I do that? Does what I have there in red on the left match that top thing I highlighted in blue? Do those two things match? The things that are blue, do they match? Doesn't the red one here have something else on the outside that this blue one up here does not have? Okay? So, because I started with this problem here in red, and it does not match my rule up top, I cannot apply the then part yet. Does that make sense? You guys remember last year you had to isolate the absolute value bars? You got to subtract 2 from both sides before you did anything? Okay? That is because we need this concept here, this particular situation, to match this rule. Is that all right with everybody? Okay. Here's when we talk about a conjecture is just an argument about something. It's just a statement. Okay, it's a synonym for a statement. Okay. Here it says I've got this conjecture that says if for all real numbers x, so any number you can imagine on the number line, any number you want. Okay, it says then the expression x squared is greater than or equal to x. If for all real numbers x, then the expression x squared is greater than or equal to x. They want us to come up with what we call a counterexample. A counterexample is a statement that makes your conjecture or your conditional statement false. Okay? So if for all real numbers x, then the expression x squared is greater than or equal to x. Okay? Maybe making the argument like this. Let's say I got to go back to if it's raining, then the grass is wet statement. If it's raining, then the grass is wet. Is there a statement or an idea or situation you come up with that would make that false? Okay, so if it's raining, then the grass is wet. Riley's saying, what if we had like a tent over the grass? Okay, it could be raining outside, but the grass underneath that tent is not wet, right? What if I reverse the statement and say, if the grass is wet, then it's raining? Are there more counterexamples to that? The grass was wet this morning, right? No, it was raining this morning. The grass was wet yesterday morning. Was it raining yesterday morning? No, but why was the grass wet yesterday morning? The dew, right? Okay. So the dew on the grass makes it wet, but that doesn't mean it was raining. So that's a counterexample to that phrase, right? Okay. Sprinklers turn on. Grass is wet, but it wasn't raining. Okay. So those are counterexamples that make our conjecture false. All right. Let's look at this. Let's see if we can come up with some values here that maybe do this. Okay. So we got to find one example that makes this false. So give me a value for x. Just any number. Somebody throw a number out. 4. Okay, so I heard 4. And then if I square 4, I get 16, right? So they're saying if this, okay, if you start with this, then 16 needs to be greater than or equal to 4. Is that true or false? Is 16 greater than or equal to 4? That's true. Okay. Drake, did you say 10? Okay, so Drake said use 10. So that's my if part. This x squared column is just for me to do a calculation. The then part is this column on the right, right? So if I start with 10, when I square it, I get 100. The then part would say then 100 is greater than or equal to 10. Is that true or false? That's true, right? Now, as you work and do more and more examples with positive numbers, you're going to always get a true number, true result. Okay, if I try 20, I get 400. 400 is greater than or equal to 20. If I try 15, I get 225. 225 is greater than or equal to 15. I'm always going to get a true result there with positive numbers. Let's try negative numbers. Give me a negative number. Say again? Did you say 60? 16? Okay. So I go negative 16. A negative times a negative gives me positive, right? So negative 16 squared would be 256. Is 256 a positive number, always going to be bigger than the negative that I started with? So that's true. Now I'm not going to do another example because that logic. You start with a negative number, and you square it, you better get a number that's bigger than what you started with, right? Because a negative times a negative is going to turn into a positive. Okay? So we've tried positive numbers, we've tried negative numbers. What's another number we haven't tried? What's the number between negatives and positives? That's usually important to us. Can I try 0? I think I heard decimals, right? And that's where we're going to go here in a moment. But let's try 0. If I square 0, don't I get 0? What about 0? Is that greater than or equal to 0? It's equal to, right? So we've tried a lot of values off our number lines. Okay? And we keep getting a true statement. And it might lead you to think, well, yeah, this is always going to be true. This statement is a true statement. But Riley said decimals. Now I'm going to talk about a specific type of decimal. What if I take 1/2? What do you get when you square 1/2? 1/2 times 1/2 turns into 1/4, right? Okay? Any number between 0 and 1, when I square it, it actually gets smaller. So is 1/4 greater than or equal to 1/2? No, that's a false statement. Okay? I've got so many true statements up there, and I've got a lot of true statements that I don't have up there that are still true. A lot of other positive and negative numbers that we could square and still get true statements. But the numbers between 0 and 1, if I square those, I'm going to get false statements. Okay? So I've got a small collection of false statements and a huge collection of true statements. But this statement, because I found at least one false, is a false conjecture. Okay? So what we're saying here is that nowhere in a mathematics textbook would you ever see this as a rule that is always true. They will never tell you ever that when you start with a number and you square it, you always get something that is bigger than what you started with. Because that doesn't happen between 0 and 1. Does that make sense? Okay. This is a very important aspect of dealing with what we call logic. Okay. And I introduced the idea of like computer programs and that kind of stuff. If you ever get into that, like computer science and interested in that aspect of things, you'll talk about logic. Okay. And if you were good at geometry, you're probably good at logic and good at computer programming. But it's a simply yes or no things. Okay. And in computers, it's zeros and ones. Okay. Turn off the circuit, turn on the circuit, that type of thing. Okay. In mathematics, we talk about our truth value as true or false. Okay. Sometimes truth values are yeses and nos. Okay. Like I said, in computer sciences, they're zeros and ones. Okay. But they are the result that you get from a conditional statement. Is a conditional statement true or is it false? Now, to show that a conditional statement is true is a very, 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 very difficult process. Because what we have to do is say that it's true for an infinite number of objects, an infinite number of scenarios. And that's hard to do. You've talked to your friends, or that you've heard them complain about proofs in geometry, or just proofs in general mathematics. They're hard because you have to deal with the concept of being able to show something true an infinite number of situations, or infinite number of times. So that's hard. Okay? To show a conditional statement is false is a little bit easier. Because to show a conditional statement is false, you need one and only one counterexample. Okay? Now, you might have an infinite number of places where your statement is true, but one counterexample is enough to say the statement's false. I could be a nice guy for 35 years of my life. Okay? It's a lot of days, right? I could be a pretty good person for, let's say, 10,000 days out of my life. Okay? But if I go rob a convenience store tomorrow, I am now a felon, right? 9,000, 10,000 days of being good, 1 day of being bad, and I'm bad now for the rest of my life. And people are going to categorize me as a felon for the rest of my life. Does that make sense? It's this idea here with conditional statements. Okay? You need to be able to show them true. You can't have that one bad day. If you have that one bad day, your conditional is false. Okay? And it's going to be difficult. You know, you be an A student. If you're going to be an A student, then you need to get A's every single day, right? You come in here, take a test, you get a D on it, you're not an A student anymore because you've shown one day that you were a D student. Okay? So that's the idea about conditional statements. Okay? And that's why they're difficult to deal with sometimes because of the idea of dealing with infinite solutions or infinite situations. Okay? And that's what that last statement there is saying. Infinite number of truths are ruined by one false. Okay? One bad egg can ruin the whole thing. All right, so we talked about some counterexamples already with these types of situations. I'm going to kind of jump over that. We'll write this one down and then we'll stop. Okay? So the negation of a statement, P. So negation just means, you guys have negated things in English. You negate things probably in Spanish class. Okay? Negation means to bring in the word not, right? Okay? So if I want to negate a statement, I'm going to put in the word not. Now, when I put that word not in, I want to make sure that it's grammatically correct. Okay? So I just don't want to randomly put it in my sentence and it not make sense. Okay? So if, the example here says, if you say the water is cold, the negation would be the water is not cold. I would not say, not the water is cold. I don't talk like Yoda, right? Okay? The water is not cold. I would not say the not water is cold or anything like that. I would make sure that I put it in there so that it sounds grammatically correct. Okay? Now, when you say the water is not cold, that's what you're telling me. You're not telling me that it's hot, are you? You're telling me it's just not cold. That's all I know. Could be lukewarm, could be hot, could be boiling. Okay, I don't know. You just told me it's not cold. That's it. Okay? When we negate something, okay, so this is the notation for my hypothesis. We use that little symbol that I think called tilde in Spanish. Is that right? Spanish people? Okay? That in mathematics, that stands for the word not. Okay? We'll pick up there tomorrow. Do some more examples, and then you should be ready to be able to do some homework tomorrow. No homework this evening.